Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, welcome all the class 6th students of Mastermind School Falaknuma so far for today's session. As you all can see on the screen, and you are well known, my subject is physics. We are in class 6th, our ongoing chapter, electricity. And today we are entering into the session number 3. So far we completed 2 sessions on knowing about the basic concepts of electricity. So today we are in 3rd session, and maybe next class we are going to close the chapter, which is our test 5 syllabus, right? So today we are entering into the session number 3, where we learn more about the terms related to electricity, some important terms related to electricity and how they are represented, their symbols, so many things to learn in the next 2 classes. But before that, before going for today's session, let us recall what we learned in the last 2 sessions, right? So welcome, Jogipet. You can see what we learned, where we started. Actually, we started with the origin, prehistory of electricity. Starting from prehistory means where electricity is observed for the first time by the Greek philosophers. From there we started. Then we learn about how the Thales introduced the word electricity. Then how charge is observed and named. There are 2 types of electric charges, positive and negative charge, where, right? Generally, atom is neutral, electrically neutral. But whenever electron is removed from that or an extra electron added, it becomes the charged body. So there are some substances which allows the electricity to pass through them, which are called conductors. Like metals, human body, all comes under conductors. And that type is which does not allow electricity to pass through them. They are called insulators. Okay. Then 3rd category is semiconductors, which partly allows the electricity to pass through them. They are called semiconductors. Like that, all the substances based on the behavior in electric field, they are classified into conductors, insulators, and semiconductors. So there are examples also again we discussed. Then when we are giving charge to a body, because I told atom is electrically neutral. One particular atom contains equal number of positive charges and equal number of negative charges. So that's why it is called neutral. But whenever you are giving the charge to a body, by so many methods are there. The first is rubbing. While rubbing, the first observed by Thales. So when you are rubbing, when you are giving the charge to a body, that process is called electrification. The process of giving charge to a neutral atom. Right? How we are giving charge? There are so many methods are there. There are so many methods for giving charge, or there are so many methods for electrification. In that first method is charging by friction. By rubbing 2 bodies, we can give charge to the bodies. Already we discussed it. When the 2 bodies are rubbed with each other, it may be umber with fur, glass rod with silk cloth, ebonite rod with the silk cloth, anything. Any 2 bodies, or comb with hair. When the 2 bodies are rubbed, both the bodies attains opposite charges. Such method of giving charge is called frictional electrification or charging by friction. Right? Charging by friction. Second one is charging by conduction. by directly contact one charged body and neutral body. When you kept contact, the same charge moves to the second body. Means by keeping the bodies together, we can transfer the charge from charged body to neutral body. Same charge will transfer. That process is called charging by electrification by conduction. Similarly, by induction, electrification by induction also, without direct contact. Suppose you have one positive charged body and you have neutral body. When you keep the neutral body near to the charged body without direct contact, due to presence of air molecules, so charge will transfer from air and finally come to the neutral body also. That method is called induction. Charging by friction, charging by conduction, and finally charging by induction. So by these three methods, we can give charge for a body, or we can go for the electrification. Then we have seen law of electric forces. So like charges repulse, unlike charges attracts each other. Very important law. That is observation made after finding out charges. When two like charges are placed, positive, positive or negative, negative, they repel. But one positive, one negative is brought together, they attract. From that, they propose the law of electric force. And this force is explained by Coulomb's law. We already have seen F is equal to Q1, Q2 by R square. That is, the force of attraction between two charged bodies is directly proportional to product of their charges, Q. Q is the charge measuring Coulomb. Q1, Q2, two bodies, two charged bodies. When they are separated by distance, the distance is R. From that, we got the formula for Coulomb's law. Very important law. Then, to detect charge, whether the body is having charge or not, if charge is there, what kind of charge? To know that, electroscopes are devised. So, electroscope is a device used to measure presence and kind of charge. So, further, there are two types of electroscopes. One is pith ball electroscope, second one is gold leaf electroscope. Both of them are used for measuring or knowing the presence of charge, kind of charge. Suppose charge is there, what kind of charge it is, whether positive or negative. If charge is not there, no issue. We can come to know that it is a neutral. By using these two electroscopes, we can measure the presence and kind of charge. And this charge can be seen. We can see this charge is effective in the nature also in the form of lightning. Lightning is the process of, it takes place between the two clouds, or cloud and earth, or cloud and air particles. When they collide, due to the charging produced between them, light will come out in the form of lightning. In the form of lightning. Okay, this is about the, all these are the methods for the electrification or charging. Okay, then already we discussed the source synopsis 2. So what are the sources of electric current? Sources. From where we can get the electricity? What? From where? What are the main source of electricity? So already I told, number one, first one is cell. Cell, you know, cell is nothing but 1.5 volt capacity will have. Cell, very small source of electricity, which will commonly used for remote controls, playing toys, watch, right? So next, little bigger than this is a battery. Combination of cells is called battery. It may be 3 volt, 4.5 volts, 6 volts, 9 volts available. Yes? When you combine the cells, you can get the battery. Apart from this, there are so many other types of batteries are there, like dry cells or Leclancher's cell or bichromatic cell. As per our requirement, you can see in two-wheelers or four-wheelers or lorries, heavy vehicles. What we'll use? We'll use the battery for self-start. Or when you are doing some DJ programs, they'll bring the batteries for us. For inverters also, we'll have the batteries. As per our requirement, as per the power you require, we'll have the different kinds of batteries. or cells. What they do all in all these cases, what happens here? Chemical energy is converting into electrical. So we are producing electricity from chemicals. By using the various chemicals, different cells will have different chemicals. So what is the main purpose of the battery or cell is they convert chemical energy into electrical energy. Some of them are dry, some of them are liquid. Right? That is a process in any of the cells or any of the sources, right? Clear? Okay. So there are various types of cells are given here. We can see how they convert the electric energy, chemical energy into electricals. Okay. You can see here there are types of cells are there. There are primary cells, very important. The classification. Cell is the smallest source of electricity, where there are primary cells are there. There are secondary cells are there. So the cells which cannot be recharged and disposed after use. Suppose if you see in your remote control, we cannot use that cells for the throughout life. Maybe after 1 year, 2 years, we have to replace them because they are primary. They are discharged. We cannot recharge them. But there are some cells are there. Rechargeable cells will get maybe a little more cost, but we'll get some charger for them. We can recharge them and again you can use. They are called secondary cells. So primary cells are those which cannot be recharged. Cannot be recharged. But whereas secondary cells are those which can be recharged. Either it may be dry cells or it may be cells of your 2-wheelers, 4-wheelers. They also, when they recharge, they pull some distilled water and they'll recharge. Okay. So all the cells, either they are small source of electricity or big source of electricity, they are classified into primary cells and secondary cells. Primary cells can be recharged. Primary cell cannot be recharged, whereas secondary cell can be recharged and you can use again and again for many years. Right? So like that, there are so many types of secondary cells are given here. First, Leclanche cell is there. So the explanation is not required for us. Different cells will use the different chemical to produce the electricity. But in all cases, chemical energy is converting into electrical energy. It may be either Leclanche cell, it may be of dry cell, right? All these are the different kinds of sources or different kinds of cells. Bichromatic cell also. Bichromatic cell. There are 3 different types of cells where we can find the conversion of chemical energy into electrical energy. Okay. So good to see many branches are joined. Clear? So cell is the main source of electricity. So it may be either primary cell or it may be either secondary cell. Primary cell is the one which cannot be recharged, whereas secondary cell is the one which can be recharged. So secondary cell can be either wet cell or dry cell in the name of Leclanche's, biochromatic and dry cell. So all these cells can convert the chemical energy into electrical energy. All these uses the chemicals, some chemicals, it may be dry chemical or liquid chemical. They convert that chemical energy into electrical and gives out electricity for us. Right. Apart from these cells, we have so many other sources also there. Right. For example, you can see the source like coal. Coal is the source of electricity. By burning coal, you can produce electricity. Right. That is also source only. Wood. From wood, you can produce electricity. From wind, you can produce electricity. From water, you can produce electricity. Hydroelectricity. Right. We can produce electricity from heat. Or you can produce electricity from even garbage. Or you can produce electricity from major is sunlight. Like that, electricity can be produced as per the demand, as per the requirement. We can produce electricity by many methods. There are so many industries are working to produce electricity from various sources. It may be by burning coal, it may be by burning wood, it may be by wind. Wind vanes will be there. From that, they'll convert into electricity. It may be from water, hydroelectricity. By flow of water, they can produce electricity. Similarly, from heat also, from heat can be converted into electricity. Garbage, whatever garbage you throw out, that will be dumped at one place and they produce electricity from that side. Apart from all these things, solar energy is very powerful. You can use solar energy to convert into electricity. You may be seeing nowadays, there are solar energy, even electrical cars we are finding, and electrical vehicle. In Japan, they are using even solar cars also. We have started electrical now, but they are in the solar cars. Means they can able to store the solar energy more than us, because solar energy is the innumerable. So much huge amount of energy produced by sun. But because we cannot store it properly, we are not using it. But solar energy can be very useful and pollution free, can be converted into electricity. So these all are the various sources of electricity apart from chemicals, apart from the cell batteries and all, right? All this comes under the source of electricity. Clear? So source is nothing but from where we can get electricity. That is important. So see, in power stations, thermal power stations or any power stations, they are sending electricity to our whole house. It is called domestic electricity, domestic purpose. So how we are getting the electricity? We are getting through transformers. Transformer can produce the high voltage or low voltage current. So through cables, they are connected to the thermo transformers. From transformers connected to our meter. Through meter, we are getting the current to our house or domestic or industrial purpose. All these electricity is produced by some or other source only. Right? Some villages, if you go, where there is an open place will be there, they'll fix the wind vanes. From that wind vanes, by collecting the wind, they'll convert that wind energy into electric energy by using the turbines. Water, where there is a flow of water is there. From the flow of water also they can produce, for example, Nagarjuna Sagar Dam. So while water is flowing, the flow is allowed to fall on the turbines and they produce electricity. There are so many innumerable sources are there to produce electricity. But thing is, how far we are using that, how much power we are saving is very important. We have to save the energy for future. You cannot save, all these are comes under non-renewable source only. They cannot be stayed for a long time. Once you are using it, will be replenished. So what we have to do, we have to store it, we have to save it. In our absence, you have to switch off the lights, switch off the fans. Saving energy is nothing but earning only. So keep saving energy. Saving energy is a very, very important slogan. Right? So why, sir, so much energy sun is giving, so much, all we are getting, why to save? But the thing is, producing is not important. There are so many industries are there which are producing the electricity. But if you save the energy, you can give to the next generations. Otherwise, there may not be wood in future. There may not be coal in future. There may not be water in future. There may not be wind because we are going for all constructions. So definitely we'll face the scarcity of this. Right? To avoid the scarcity, what we have to do? We have to save. Like how you are saving the money for future, we have to save the energy also. Such a wonderful form of energy is electric energy. Okay. So we'll go for the next synopsis 3. You can see on the screen. Very interesting terms will come across. We'll get the very important terms related to electricity. So in that, the most important one is electric circuit. So before going for explanation, let me show you one video on the electric circuits. After seeing video, so I'll give the explanation for you. What is circuit and how many types of circuits are there? Where we can see the circuit in our house also. Okay. First, just see the video related to the
electricity. Introduction. You see electric bulbs, LEDs, fan, refrigerator, television, air conditioner, juicer in your house. These are called electrical appliances because they all work when electric current flow through it. Electricity is the presence or the flow of electric charge. The term electricity is derived from electric energy, a form of energy that is the flow of electric charge. The chemical energy of coal, natural gas, nuclear substance, uranium, polonium, water, etc. is transformed into electric energy in thermal, nuclear, hydroelectric, and wind power plants. Currently, electricity is one of the most useful and efficient energy used by the people in the house. Electric cell. Ever thought, how do a bulb in a torch, alarm clock, wristwatch, camera, radio, and many other devices work? From where do all these devices get energy? You might have observed that a small electric cell is placed in these devices that supplies electrical energy. If you have seen an electric cell carefully, it has a metal cap on one side and a metal plate on the other side. A positive sign is marked on metal cap called positive terminal of the electric cell, and a negative sign on metal plate side called negative terminal of the cell. Every electric cell has these two terminals. An electric cell consists of many chemicals inside it. A chemical reaction occurs inside the electric cell, results into flow of electron from negative terminal to positive terminal of the cell. When all these chemicals are used up, the electric cell stops producing electricity. In this case, the electric cell is replaced with a new electric cell. Aim: to find out the source of electricity in an electric torch. Materials required: an electric torch, 2 electric cell. Method: take the torch and open its back end. Insert 2 electric cells inside it in such a way that the metal cap of the cell is placed inside. Now, close the end by screwing it. You see that the bulb lights up on switching on the torch. Now, remove the cells and again switch on the torch. The bulb does not light up in this case. Conclusion: this shows that the source of electricity in the electric torch is electric cell. Electrical connection. The connection of an electric device with the electric source through the electric wires is called electrical connection. An electrical connection is required to make an electric circuit. The working of the wires when connected with the electric devices can be explained with an activity. Take a torch and look at the bulb inside it. Take out the bulb with the help of an elder. Now, you see that a thin coiled wire is fixed in the middle inside the bulb that is covered with glass bulb. When you switch on the torch, the bulb glows. The thin coiled wire in the middle emits electric circuit. The interconnection between the electric components is called electric circuit. The electric components work only when the circuit is complete. That means the current flow through the circuit. A bulb emits lights only when the positive and the negative terminal of the cell is connected to the bulb through a wire. This type of arrangement is a good example of an electric circuit. Any disconnection of wire from any electric component breaks off the circuit. A complete electric circuit provides the path for flow of electric current. The electric current flows from positive terminal of the cell to negative terminal of the cell through wires. Sometimes you see that the bulb does not light up even after the circuit is complete. This may be due to the fused bulb. That means the filament of the bulb is fused, break off, and the circuit is break off and current does not flow through the bulb and bulb does not light up. Symbolic representation of basic electric components. In general, when we draw an electric circuit, we represent battery, electric switch, etc. by specific symbol. Cell is represented using the symbol. Battery is represented using the symbol.
Combination of cells.
Switch is represented using the symbol. Bulb is represented using the symbol. Electric switch. You usually switch on and off TV, fan, light, mobile phone, charging from a switch provided on the electric board. From the activity done, we get to know that the bulb lights up continually when the circuit is complete. But if you want to light off the bulb, you have to break off the circuit. That means you have to use an electric component that temporarily breaks off and connect the circuit. This component is called an electric switch. A conducting material is used in the electric switch. Various types of electric switches are used. When the switch is on, the circuit is said to be closed circuit. In this case, the electric current flow from the cell to the electric device connected to the circuit and device is in operation. On the other hand, when the switch is off, the circuit is said to be open circuit. In this case, the circuit breaks off and electric current does not flow through the electric device connected to the circuit, and thus the device does not work. Electrical conductors and insulators.
What do we have seen?
Metals are good conductor of electricity and hence used in all electrical connections and circuits. In circuits, metal wires are used. Suppose metal wires are replaced by jute rope in electric bulb circuit, the bulb wouldn't lighten up. You know that bulb does not glow when the free ends of the wires are in contact with some of the materials. That means that some materials allow the current to flow through them and some do not. Materials which allow electric current to flow through them are conductors of electricity. For example, iron, steel, copper, silver, lead, tin, etc. On the other hand, materials which do not allow electric current to flow through them are called insulators. For example, wood, wax, plastic, cotton, rubber, etc. Electrical switches, wires, sockets are made of conductors, while the outer cover of all these electrical components are covered with insulators. Take the electric circuit in which the electric bulb, switch, electric cell are connected with a metal wire. Now, replace the switch with an iron nail. Now, connect the second wire to the other end of the iron nail. You see, the bulb lights up. That means the iron nail allows the current to flow through it.
Right. Hope you are clear about the complete clarification is given about the basics of electricity till the conductors, insulators and all. Right. So we have finished with the synopsis 2, which is our syllabus for the test 5. So only synopsis 1 and synopsis 2 is there. You prepare well. You turn back to the worksheets and you can solve the worksheet also. In next class, again, we'll try to discuss about the worksheets. But before that, let me introduce about the synopsis 3. Right. When you see synopsis 3 here, complete basics will come. Basics of the electricity. Overall terms related to electricity will come. And see here. When you come to synopsis 3, what we are discussing about? Electric circuit. Simple way I tell. Suppose if you go to your house, switch on the light. Switch on the light, we can see the light is glowing. Switch on the fan is moving. How it is possible? What is there between the switch and fan? There is one cable connection is there. Cable connection is there. We cannot see. It may be inside or some of that may be outside also, but that is concealed nowadays. Olden days we used to have the pipes, on the top, wire is passing through that. But nowadays they are concealing inside the wall only. So you cannot see the cable, but still there is a connection is there. Such connection between number 1, source of electricity. It may be either battery or cell or generator, transformer, anything. Second one is consumer. Consumer means utilizes. Bulb is a consumer. TV is a consumer. Laptop is a consumer. Mobile is a consumer. Third one is key, or is also called switch. Very important. Without switch, you cannot operate the electricity. Otherwise, and fourth one is cable or wire. Cable or wire. These 4 are the basic requirement for constructing a circuit. For example, in our house, if you see, we have meter, electric meter. from where current will come to switch. That is, electric meter is the source. Switch is the key. Consumer is the fan or tube light, and they are connected by cable. When these four are connected through each other, such arrangement is called electric circuit. How it's shown in the only these are the connect. These four are minimum requirements. Maybe there may be more sources, there may be more consumers, there may be many switches, there may be any number of wires. The cable also conducting wire. It may be silver, copper, aluminum. Gold cannot make because costly gold and silver. They are good conductors, but you cannot bear it as a this one. Okay. So that is simple. That is called electric circuit. Whenever current is flowing through the circuit, switch is on. When switch on, right? When switch is on means that is called closed circuit, open circuit. Open. Circuit is open means switch is on, means current flows. When circuit is off, switch is off. When it's off, that means that is called closed circuit. Sorry, this is reverse. Closed means current flow, open means current does not flow. We are opening the switch, we are off. When switch is off, current does not flow. That is called open circuit. So electric circuit can be either open or closed. When you close, current passes. When you open, current does not passes. Simple. So you can observe anywhere. When you switch on the light, light will come, switch off, light will not come. Why? Because the circuit is either closed or open. So in every circuit, in our house contains so many circuits which are connected to fuse. All the wires will bring and connect to so many fuses are there. Each fuse controls each room. Right? They are connected. Such an arrangement is called simple electric circuit. And so many electrical devices we'll use switches, we'll use bulb, we'll use the batteries, we'll use the wire. All these are represented by some symbols also. There are some symbolic representation for the all electrical. Right? All electrical things will represent by symbols. Like battery, it may be battery, or it may be a wire, it may be a fuse, another important one. Fuse also very important for us. What happened that fuse? Fuse controls the high voltage. If more current comes, fuse will burn and protect our appliances. If fuse is not there, directly all our fridge and TVs will blast when high voltage comes. So it completely controls the circuit. Circuit is under the control of electric fuse, which is made up of a material of low melting point. That will come across later about the different types of fuses are there, right? There are different types of fuses nowadays. We are getting MCBs, miniature circuit breakers are there, latest. Many are there to discuss in the next classes. Okay, so the third synopsis will come for the next test, test number 6. You have only 2 synopsis for the coming exam, where we have learned about the so many things, starting from the basics. So basics of electricity to what we learned. So first one is basics, where we study about the history of electricity, right? Then we discuss about the electric charge. What is electric charge and what are the units? There are 2 types of charges are there. Types of charges, types of electric charges. There are 2 are there, positive and negative. Then unit of electric charge, which is nothing but Coulomb. Coulomb is the name of the scientist, Coulomb. Then we discussed about the conductors, insulators, and semiconductors. Right. Then we enter into the sources of electricity. Sources. In sources, we discuss about cell, battery. In this battery, again, there are 2 categories. Primary cells, that is cells or batteries. We come across primary, secondary. Right? Primary are which cannot be recharged. We cannot recharge them. cannot be recharged. Whereas secondary are rechargeable cells. Rechargeable. We can recharge and you can use again. They may be dry or liquid also. So in that we have seen the varieties are there, like bichromatic cell, Leclanche cell. What all these all do? They all will do, they converts the chemical energy into electrical. Chemical to electrical. All these, whether these are a cell or dry cell or Leclanche cell or bichromatic cell, all these converts the chemical energy and gives out electrical energy for us. Apart from this, there are so many other sources also there. That basically we discussed coal, wood, wind, water, sunlight, sun energy, solar energy. All these also used for the producing the electric current. Right? So these all points covers the up to synopsis 1, synopsis 2, which is the syllabus for upcoming test 5, which is on 25th November. So go through this, and related to these two topics, there are some worksheets also there. You need to practice as per the availability of time. I'll give for you, but you have to do your own practice about this topic. I clearly given the concepts. So remaining part is yours. Okay. So these are the important topics what we covered so far in electricity in last 3 sessions. So in next class, we'll discuss more about the electricity, and we'll enjoy more videos to know more about the electricity, right? So that's all for today. You can have some task here, home task or homework. Name sources of electricity. So many are there. You can write any sources and define electric circuit. What I introduced in the synopsis 3. These are the 2 home task questions for you. Note down these questions in your notebook and write the answers. Take the signatures from your teachers and parents. Right. Right. So thank you all of you. Have a wonderful day. Thank you.